So, hello everyone. Welcome back to ShaktiCon 2021. Hope you enjoy the conference till now with all the informative sessions. We are up with more exciting talks ahead. We have Mehrnoosh Monshizadeh with us. Mehrnoosh is working at Nokia Bell Labs Research Department as cybersecurity specialist. Her research area includes utilizing and optimizing artificial intelligence for IoT security, drone robot security, digital health security, and cloud security. She has been working previously on development of LTE core network and lawful interception. So, as we all know, 5G security is becoming the key technology serving Internet of Things and subsequently Internet of Drones connectivity. So, our speaker will be giving us an insight into the Internet of Drones security. Hi, Mehrnoosh.
Hello.
Yeah, so this will be a
Okay.
30-minute session, and I will be reminding you 5 minutes prior so that you can conclude it well. Okay.
Sure.
Thank you. Over to you.
Okay. Hello, everyone. Welcome. In this presentation, I'm going to talk about Internet of Drone or drones that use cellular network for communication, their application, security concerns, and finally I introduce a security mechanism to detect cyber attacks targeting these networks. So, as we all know, UAVs or drones first been used by individuals as standalone components for entertainment purposes. However, recently they got attention of private enterprises and government entities for various applications. Obviously, similar to other smart devices, they need a fast and reliable connectivity. In this figure, you see that entire drone communication is carried by LTE network, such as authentication messages, flight control messages, transferring all collected data to cloud for further analysis is also done by LTE network. And then here, when it comes to IoT connectivity in general, we emphasize on 5G networks rather than previous generation. Why? Okay, because 5G network delivers extreme broadband gigabytes of data connectivity with very low latency and high reliability that allows immediate communication for IoT devices that carry critical missions such as emergency services. Let's have a comparison here between 4G networks and 5G networks. We see that 4G networks, they have been more about connecting people. Now we have connecting the things. Earlier, we had 11 billion of subscriber or people connected to our or currently connected to our networks, while for 5G, we would have tens of billions of devices. Average revenue per customer for people has been $30 per month per each customer or per each subscriber. Now we have $3 per month. It's a little, but we have many of those devices again. And in 4G or for people, we had data pricing based on the volume of data, while here for things, it's based on the value of data. There are IoT devices that they don't consume much data, but they need high reliability and very low latency, again, for mission critical application. So then the price will increase based on that features. And then quality of service or quality of experience earlier has been best effort for everyone, but now it is based on the application and also based on the service level agreement. And finally, the security has been important for people, but now it is critical. There are applications, as I mentioned, like emergency services, health, public safety, that the difference between Normal functionality means a difference between death and life. So here we can see that in 5G robots and drones, we put them in a different category, while they are actually are applied for many of these areas, such as automotive industry, smart cities, health, and so on. Let's talk about some of the use cases that are considered for drone or unmanned aerial vehicles. In general, drone networks have 4 main use cases: public safety, emergency services, health. The second is smart city, industry, and finally transportation. I give a very short one example of each of them. For example, for a street, police drones patrolling a street, they collect information about any incident. We have for emergency services, searching for missing person with the thermal cameras installed on drone, or delivery of medical supply. Then we have a perimeter that drone are used for border inspection or inspecting closed area or industrial area. Then we have drones that are used for prevention, finding dried or hot spot in forest in order to prevent future big fires, fire monitoring in cities, evacuation warning, and then if we put all others like air quality, water quality, or inspection in one category, we can say any leakage of gas or chemical, or even air pollution can be detected by drones. And also for transportation, that we are using drones for point-to-point delivery and or parcel delivery. So what are the security concerns? As we mentioned earlier, 5G network introduces new use cases arising from IoT, subsequently IoT networks, where an anomaly in the original function means difference between life and death. Therefore, considering a secure and reliable communication would be a major concern for private enterprises and government entities. In brief, our security mechanism for this type of application must have the highest scalability against huge volume of data collected from numerous devices. They should be robust against any new type of attack. They should be automated, so they are self-learner, self-adaptive in detecting and reacting to different types of attacks, and of course with minimum human interaction for analyzing the data. And finally, they should have some orchestration mechanism to distribute result of analysis to other site in order to prevent duplicate analysis. So let's now start to see some of the attack scenarios. When it comes to cyber attacks on drone can be used either by attacker as a weapon to attack other parties, such as other drones, cellular network, and so on, or they can be directly targeted by an attacker. Let's talk first about the first scenario, when the drone is itself a victim of a cyber attack. Then drone are spoofed to probe or corrupt their data. It is very important actually, because if we have law enforcement drones or industrial drones, because of leakage of information, of course they don't want that this information will be still. Then we have a takedown, lockout, or takeover of drones. We have sabotage or destruction of drones. It can be any kind of SIM card theft or device theft itself. Then it is a drone identity theft, manipulating a system with wrong data or wrong location. And when it goes to second scenario, when drone is used by attacker as a weapon, they can steal information of other drones or poorly protected cellular Wi-Fi network. They can probe or corrupt other drones' collected data. They can corrupt other IoT devices or smart devices, such as home appliances, light bulbs, or car charging meters, and many other appliances. And now we know some of those attacks. Let's categorize them. So here we see three main security requirements that must be considered while designing or applying any security platform for our IoT network. These requirements considered actually not only for IoT, but for any technology that needs to be protected against cyber attack. The model is invented in 1998 as a CIA, or confidentiality, integrity, and availability, by Parker, has been followed for several years by various standardization organizations such as ISO. And it categorizes a security concern, as we mentioned, in three main groups. The first one is any kind of confidentiality concern, such as unauthorized access, privileged access, or data or information leakage. The attacks that, some of the attacks that we can address for this group could be probing, replay attack, eavesdropping, falsified IoT or drone's identity, location tracking. Then we go to availability. We have in this category data loss, configuration loss, resource unavailability, and for this group we can name denial of service attack, channel jamming, or GPS spoofing. And finally, integrity. That goes back to any... And then we have integrity that goes to any data tampering, data corruption, man in the middle, malware injection, message forgery, or access control modification also goes to this group. So, sorry, somebody had question? Okay. Then now we go to security mechanisms that are available for drones. They are either software-based or hardware-based or physical-based security services. And hardware-based, of course, are all of those security mechanisms, such as accelerated cryptographic methods. They are hard-coded. Or they are software-based, they are dynamically running on software. And then finally, of course, physical security services. Because we concentrate on intrusion detection system, I highlighted it here. And then also, this security mechanism should cover either the cloud network and their application, the communication channel or connectivity network, and then or the components of the whole network. And again, intrusion detection sits in the communication and connectivity. So what is the intrusion detection system? It is a system that monitor and analyze events. Either it takes a misuse detection approach or anomaly detection approach. For misuse detection, it checks signature of attack. And actually, if anything is similar or exactly matched with that attack signature, it will be considered as malicious, or it has a pattern of the benign traffic. And if it anything varies from that benign traffic, it considers as anomaly. It has its own challenges. It is a static signature. It relies on static signature. It can have a limited number of rules defined, and also it's not very well suited for AI-driven attack or intelligent attack. It has also long processing time. That's why we move to ML-based, AI-based, or data mining-based intrusion detection system. They apply algorithm to extract pattern from data, dynamically learn from those patterns, identify abnormal pattern and update their structure based on the new pattern. As we see, it is not exactly matching with one signature, but it works based on the texture of the traffic and the similarity, actually, rather than exact matching. And it's just a review how the data mining technique works. First, we collect the data, and then data is pre-processed to remove all of the duplicate data or handle the missing values, or for example, convert or split IP address to separated or numeric values. Then we have data transformation that convert again numeric values to nominal attributes to increase the model efficiency. And then finally our own algorithm itself that has different parts, like a feature selection, feature extraction. I talk about it later. And finally evaluation of our model. So here there is one example, or our test bed for a UAV system. It's as I said, it's a test bed. We are using LTE network. It's sufficient for one drone, and then here you can see the components of this architecture. We have drone, we have eNode B LTE network, we have a security mechanism or anomaly detection mechanism that locate in core network, and then cloud server and ground control station. And then in high level, the communication here is carried over TCP or UDP protocol, which encapsulated protocols drone are using under the TCP or UDP. It is of course company specific, but in general I can shortly review. There are, for example, possibility to use RTSP, gRPC, RTSP, REST or ROSLink. They can be used for transferring, collecting data such as video, image, or any sensor information. RTSP is can be over TCP or UDP. Then REST is only over TCP, and ROSLink is over TCP or UDP. We have MovLink, gRPC, UAV CAN, or MQTT that can be used for command and control and telemetry information. MovLink can be again on TCP or UDP. Then gRPC can be on TCP, and again MQTT can be over TCP. And what are those messages? Command and control and telemetry messages have all kind of status check, health messages, or position of the drone. Waypoints are information regarding pre-planned flight destinations. Mission commands are all commands executed until a mission is achieved, like takeoff, turn, land, collect info or data. And the user data is the actual data collected by drone, video, image, sensor, or any measurement. So what are the vulnerabilities? We should know the vulnerability of these links so we can design a mechanism for that. For MovLink, it doesn't provide actually any CIA or confidentiality, integrity, and availability. So it is exposed to many of attacks. UAV CAN also has no shielding. It is not good for mission critical system. Then we have gRPC. It uses SSL and TLS to authenticate server. It also uses encryption. So it has some kind of protection, but still it has its own vulnerabilities. Then we have ROSLink that has no security, encryption, or authentication. We have RTSP and REST. Both of them are using a web-based mechanism as HTTP, so they have similar vulnerabilities. And finally, MQTT that only has authentication mechanism and no encryption. So here is example of a network. I am explaining it. We haven't used it yet in our testing. Our testing is just either normal network traffic scenario or this simple scenario, but it can be extended to a scenario that we have two factory side. In right side, you see drones or robots, whatever. The information is collected, sent to IoT gateway. IoT gateway or industrial IoT gateway does the primary monitoring and analysis, that it sends it to core network. Either it is a separate MVNO or all of them are under one MVNO or one enterprise LTE or 5G network, but located in different sites or factories or whatever. Based on the application or use case or priority of the mission, the data will be transferred to anomaly detection for further analysis. I will explain this module in details. In this, if this module detects the traffic as malicious, then it will inform the IoT gateway in the right side, also through the orchestrator. It sends the result of analysis to other sites in order to prevent duplicate analysis. That's what we were talking earlier about orchestration and automatic analysis. And also, if drone wants to move from one side to other side, it is prohibited to enter to the other side. So for that, we should consider that there are various type of drone communication. Either drone communicate with the other drones in same MVNO or same cell, or it is between different cell, but inside one MVNO. It is between two different MVNOs, or drone is moving from one side to the other side. Later, I show the messages that is carried between drone and mobile network, and why I put it here, because there are two parts for drone data. Either it is control plane or user plane. Control plane is all of those messages that is transferred with the LTE network. So it is just like an ordinary user with SIM card. All of those paging, creating the bearer or authentication messages are all similar, so they follow the same mechanism or specification that defined for ordinary subscription. But of course, when it comes to user plane and header, then the matter is different. So, and then here I put two different scenarios when the drone itself carries the SIM card. So either it wants to attack or communicate with drones in same cell or the other cell. Everything goes to through the core network. That's why we put our anomaly detection in core network. Or even the drone is seamless, but because it uses the LTE network, still there is LRC or local robot controller that carries the SIM card, and drone are connected via Bluetooth or Wi-Fi, and then this LRC or local robot controller is communicating with eNode B. So in any case, it uses the LTE network. So, and finally, our hybrid anomaly detection model or security platform. It is designed in Nokia, and it is patented actually for Nokia. That's why I can present it. So it is AI-based anomaly detection platform. It follows all of the aspects that we mentioned for 5G and for IoT use cases should be considered. For scalability, we concentrated on computation time. We tested it to check the minimum computation time. We check the robustness against various data sets with, of course, also for scalability, various data with various size has been tested with this model. For robustness, we checked it not only with data, known data or supervised algorithm or technique, but also against unknown traffic. So we managed to fix overfitting issues with the automated feature extraction method. And then finally, we also manage to fix or overcome the challenge, data imbalance challenge, that all of them affect the robustness. And for automation, I talked earlier, we have dynamic feature extraction. We have cluster analysis, and we have orchestration. Orchestration, we have IoT orchestrator to distribute the result of analysis. For cluster analysis, we are planning to it's not yet done, but we are planning to do the cluster analysis with an algorithm instead of human analysis, and already we have the dynamic feature extraction. And finally, it is the model. In first part, we have protocol analyzer. It divides the traffic to two categories: vulnerable protocol and non-vulnerable protocol. Vulnerable protocol are already predefined, such as UDP and TCP, and non-vulnerable protocols such as streaming protocol. Still, they go to an algorithm for further analysis. If algorithm detects that this traffic carry attack or this protocol carry attack informs our counter and prioritization, and it decides that it consider that protocol as vulnerable or not. It really decreases. We have the result of every part of this model published in journal papers, different journal papers. So really the protocol analyzer decrease considerably the computation time. Also, it divides the traffic based on it. It is UDP or TCP, because these protocols have different nature and they require different algorithm to analyze them. And in addition, it also helps the scalability because they run parallel. And then this part only labels the attack in very general level, but it doesn't say a specific type of attack. And then traffic goes to rule extractor and the duplicator. If the system already knows some of these attacks and already is protected against those attacks, for example, we have rules against some of those patterns in a firewall, then it doesn't send it to last part that it is a dynamic machine learning for further analysis. It just drops that traffic or forward it to the other part of the system. But then at the end, we have our algorithm 5. It is actually it has two parts. It has a classifier and it has a clustering. In classifier, we, from the input traffic, we detect the already known patterns or attacks that are predefined, and the rest of the traffic that is unknown will be forwarded to clustering. Here, it is a non-supervised algorithm, and we are using for this part actually a clustering algorithm that doesn't need to know the number of cluster. So it just yes.
Hello.
Yes.
Sorry to interrupt, but can you wrap it up like 5 more
Yeah.
minutes?
Okay, so I just I tell that we used it against, as I said, the different data set from with the different attacks and different size, and then also with custom data sets. The features that are used are both network traffic features and also drone specific features on both header. Payload, we haven't done the analysis, but the header for example, Moblink is one example. And then the attacks are taken from network traffic attack and they are injected to drone traffic. And then as I said, we were using earlier feature extraction and cross-validation, but we automated it because of the overfitting. We used variational autoencoder. We used many different techniques, and based on that, we selected conditional variational autoencoder that instead of selecting a subset of feature, it just select all of or encode all of the features and makes a new features from all of them, but nothing is removed. And finally, for unknown traffic, why it is important to label it, because a big portion of our data, about 40%, is unknown traffic. So it's really important to be considered. For that, we used DBA Scan, but combination of DBA Scan and different methods. Because the DBA Scan alone couldn't have of course, it doesn't need the number of cluster. It doesn't relate it to shape of size of cluster, but it is extremely density based. So we had to combine it with, for example, variational autoencoder and association matrix. And again, results are published in a journal paper. And what is future work for our work? It's replacing the security investigator to analyze those clusters, because now the human decides based on the texture of the cluster or size of the cluster, is it attack or not, but later a machine does it, then payload analysis, and finally analyzing AI-driven attack. And sorry that it took time.
That's fine. Thank you, Mehrnoosh. That was a really informative and wonderful session getting to know about 5G, drones, and security. So
Thanks.
now we will move on to QA session. So I'll I'll read out the questions for you, Mehrnoosh.
Okay, I am just.
So there's a question. TCP is a session-based protocol. How drone security provided throughout a session? Are the algorithms robust?
Yes, actually, we are not. If you mean session-based, flow-based, we are not analyzing based of flow. So we are analyzing per packet. So it is robust because it analyzes each packet arrived. I don't know if I answered it or not. And it is network-based. We have host-based or we have network-based. So if you mean that it is network-based, and if you mean flow-based or packet-based, it is packet-based.
Okay, so next question. Are there any simulation tools for Internet of Drones?
Okay. Yes, there are tools. I can provide you a list. I don't know if you have my email address probably, but currently we are not using any simulator for that. Either we have the traffic from real lab, real drone, or as I said,
so
we
next
are
question.
mixing. Yeah.
So Shamika, I think, yeah, she's curious to know if the performance of autoencoders and BAE-GAN for this use case. How did the use of these methods improve the performance?
Okay, as I said, one major problem that we had with other methods of feature selection, all of them, either you had overfitting issues, or you had to manually run your model several times and take mean of that, and it was not proper. What we did here, we haven't removed any features. We used all attributes or all features. We just converted them or decoded them to a smaller dimension. And then it is called actually data generalization, or your model is fit to all types of data, and it increases greatly the performance of your model and actually precision. We, rather than accuracy, we work on precision and recall. So I don't know if I have time, I can show those slides about our result. Otherwise, again, you can see the result in the IEEE Journal of Artificial Intelligence. You just need to search with my name at least and find this with variational autoencoder or data generalization, and then you will find the result.
Okay, cool. Last question. How jamming can avoid in the drones?
Okay. The jamming is when they add too much noise, or ratio of the signal or benign signal is much to the noise is decreasing a lot. So there are methods that either it is, as I said, intrusion detection, the old version of intrusion detection, that they have exact signature for those noise. It is known to the network, or you are using the dynamic machine learning. So ourselves, we haven't tried any jamming or noise, but probably you can find methods for I think it is a perturbation methods that can protect your network about jamming.
Yeah, that would be for the Q&A session. Thanks a lot, Mehrnoosh, for this wonderful
Welcome.
session.